Hello everyone, welcome back to another new video. We have one most important question, and this question is asked in 2020 fall. Okay, this is taken from the final university examination. Okay, and such type of question is repeatedly asking in our examination. So this will be very important. Okay, so let's solve this question. So first did the given data. So in the question you can see here, gravity ropeway 2 inch of Trishul river was replaced by a single 2 inch arch. Okay, 2 inch is replaced by the 2 inch arch. The same ground to sustain quality life of the Malayu people. This is going to make for the Malayu people. The span of river was 100 meter. The span is given 100 meter, and the center rise is 6 meter. Okay, a newly constructed arch was subjected to uniformly distributed gravity load, and UDL is given 50 km throughout this whole span. Okay, this 50 km is acting throughout this whole span. You can see here, this is our 50 km, and this is acting for this whole span. Okay, suggest a suitable value of horizontal thrust when you calculate this horizontal thrust, and we have to draw the BMD. So we need to carry out these two, bending moment and horizontal thrust. Okay, and this 50 km UGL is acting for this whole span. Okay, and the span is given 100 meter, and rise is given 6 meter. So these all are the given in the question. Okay, so first write all the given things here. So according to question we can make this arch. Okay, here this is in support, and here also in support. Okay, and according to question, this 50 kN UDL is acting for this whole span, so we can make this, and the span is given 100 meter, height is given 6 meter. Okay, so as we know, whenever the UDL is acting, okay, for the whole span, then we have the formula for the horizontal thrust, WL square by 16 years. Okay, this is our formula. This is for the whole span. You can see here, and as we know, for the this is acting, this UDL is acting for the whole span, and if this UDL is acting for the half span, then we have to just divide this formula by 2. So it means for the half span the formula will be 8 years, and we have to divide by 2. So it means WL square by 16 years. So for the half span the formula of horizontal thrust will be WL square by 16 years. So this is just I am give some idea for the half span. Okay, but now in this case we have full span UDL, so we have to use this formula WL square by 8h. So the value of W is, that is 50, so we need to take, and the value of L is 100, so L 100 square by 8 into H. H is 6, so 8 into 6. So finally from here you can see we get the value of horizontal thrust, that is how much, 10416.67 kilometer. Okay, so finally with the help of formula, this WL square by 16 8s, we can directly get the value of horizontal thrust, that is for the full span UDL. Okay, now we have to also draw the BMD. Okay, so for BMD we need to calculate the value of moment. Okay, so for this moment calculation, in very first we need to find out the value of this BA and BB, horizontal reaction, and for the B, horizontal reaction at B. Okay, so for this you can see here we have to take summation Fy equal to 0. So let's apply the this case. So these two will be acting upward, so these two will be positive, BA plus BB. Okay, and this UDL is acting in the entire span, so it means 50 into this 100, 50 into 100. So this total load will be acting here, this is downward, so this will be negative, and it is going to that side. Okay, and after that side it will be positive, so 50 into 100. So from here our equation will be BA plus BB equal to how much, equals to 50 into 100 means 5000. So let us say this is equation number 1. Now if we take the moment about a section, so let's take moment at section A, okay, and we are going to take clockwise moment positive, okay. So for this, okay, so okay, so moment about A equal to 0. So from section A you can see here this load is anti-clockwise, okay. For the calculation of moment we need to remove these two value. Horizontal thrust we don't need to take consideration, okay. We have to just take the reactions. So this VB is acting anti-clockwise, so VB into 100, so it is taken minus because anti-clockwise is minus. Now this 50 kN acting in 100, so 15 into 100, okay. This is load and this is acting in the center, so distance will be 50, so this is multiplied by 50. 150 into 100, that is load. 50 into 100 load, and it is acting at a distance 100 by 2 means 50 meter, so we need to multiply this 50, okay. And minus this is anti-clockwise, so take a negative, so minus VB into 100, so we have written over here, okay. And from here we can get the value of VB, that is 2500 kilonewton, okay. And when we put this value in this given equation 1, okay, so from here we get the value of VA, that is this will be also 2500 kilonewton. Now as we know, the formula of W equals to Y, formula of Y equal to 4HX, okay. Don't need to that, we have already here, you can see here y equals to 4hx l minus x by l square. So the value of h is 4, so we have to put 4, l that is 100 minus x, so you can see here this is acting 25 meter, okay. This is already given by the question, okay. So this l is 25, this this section is taken value x, and the value of x is 25, so and l square, l means this total 100 square, so the value of y we can easily find with the help of this formula, and which is calculated 4.5 meter, okay. So from here you can see we have calculated three different parameters. First one is horizontal thrust we have calculated. Second, we have calculated value of BA and value of BB. Now we have calculated also YD, where this YD, that is 4.5 meter, will gives the point where this maximum moment will be offered. So from left side you can see here at a distance of this from A, at distance 4.5 meter, the maximum moment will be offered, okay. So as we know the distance, now we can directly calculate how much that moment will be offered at a point of 4.5 meter. So for this we need to calculate the moment, and you can see the moment can be calculated directly with the formula force into distance. As we know, moment means generally force into distance. So for this you can see here, if we need to calculate the moment at this section, then this BA will be acting clockwise. So BA means how much? 2500 into this distance will be 25. From here to here this is 25. So 25 into 2500. Now you can see here this BB is acting anti-clockwise. So BB means this 2500, okay. Okay, so for this you can see here this horizontal thrust is acting for a distance how much? 4.4 meter. So from here you can see this will also rotate like this, okay. So anti-clockwise, so it can be taken h into distance, that is 4.5. So the value of h is this one, okay, and distance is 4.5 meter, that is the value of y. Okay, we have already calculated the 4.5. So this will be moment, this is given by the due to this horizontal thrust. And now another you can see here, this load is another load is also acting here. Okay, and from here if you calculate the value of moment, then you can see here for this section. Okay, here you can see for this section moment will be acting over here, this will be anti-clockwise. So from its section D, okay, we have the value of this load is 50. So 50 into 25, we need to calculate 50 into 25, and this is acting in this 24 meter, and which is acting at the center of this. So the distance will be, we have to multiply force into distance. So the distance will be half of this 25, it means 12.5. Okay, and finally we get the value of moment, that is minus 0.015 kilometer meter. Similarly, for the moment at C, okay, at moment we need to calculate the moment at a point C. Okay, so for this you can see here. Similarly, this BA, that is 2500 will be acting at a distance 50 meter. So you can see here this for this moment C, moment at C, we can just use the value of BA into half of this 50. So BA is 2500 into 50, and minus this, this is clockwise, so it is taken positive. Now you can see here we have two different load. Okay, so from here we can see we have two different load. Okay, that is due to this left side and due to this left side. So from here if we calculate for the left portion, then this it will this load act like this, and this will be anti-clockwise. Okay, so for this we need to calculate 50 into 25. Okay, 50 into this one 50, this is the load 50, and this is acting at distance of 50 meter, half of this. So it means 50 into this w load into distance, so 50 into 50, and this is acting half of this span, so distance will be half of this 50 means 25, so we have to multiply by this. Okay, this is anti-clockwise, so it is taken negative value, you can see this is taken negative. Similarly, for this right portion we need to calculate the moment for this section, and this value will be also similar. Okay, similar to this w into length, so it means 50 you can see here. Okay, for this you can see here we have another load, that is this horizontal thrust. If we calculate the moment at section C, then we have another moment due to this horizontal load. You can see here this is also acting. In this case, this horizontal thrust is acting here to here, that is anti-clockwise. So it should be also taken negative value. Okay, and the value of S is there 1.1041.67, and the distance is taken. This is you can see from C here to here, the perpendicular distance is 6 meter. So we need to multiply by this 6. So this value becomes minus 0.02 kilometer. Now we have calculated the maximum moment at D, point D, and at point C. Okay, and we get maximum moment at D is minus 0.015 and C minus 0.02. So which one will be the more greater value? At C. Okay, at point C moment will be maximum, because this is the middle portion. So now we need to make the bending moment diagram. So you can see here, as we have calculated uh, the value of C, that is 0.02, which is the maximum, so we need to take this value. Okay, and at point D we have calculated 0.15, and point E 0. Same D and E will be occur, because this same UDL is acting in left side and right side, so these two value will be same, and we have to just give this curves and take this value as a minus. Okay, because this is the UDL case, so we need to take curve. Okay, in this way we can make a bending moment diagram. So we have calculated the maximum moment at D point, at C point, and we have also drawn this value in this bending moment diagram. Okay, so I hope you guys understand very well. So in this next video, we will also do some numerical related to these two hinge arcs. Okay, so thanks for watching. Stay connected. Thank you very much.